morning and welcome to the 2024 National Plastics Expo. My name is Ryan Hayford. We are live here at the Endeavor 3D booth. Throughout the week, we will have several presentations on 3D printing at 9:30 and 11:30 in the morning. So if you have any interest in some of the topics, please come by and we'll be happy to share that information. Today's presentation, we'll talk about the business of additive manufacturing, and we'll talk about the differences between purchasing equipment versus outsourcing to a contract manufacturer. My name is Ryan Hayford. I've spent the last 15 years in additive manufacturing, in sales direct, sales channelment, executive marketing, and business development. So I have a unique perspective on what it takes to sell 3D printing equipment and at the same time talk about contracting services. As you will tell from our booth here today, there is Endeavor 3D, who is a contract manufacturer representing the HP 3D printing line, both polymers and metals. So let's talk a little bit about who Endeavor 3D is. Endeavor 3D is an HP digital manufacturing network partner that has been tested and rigorously approved for high quality, repeatable production for both polymer and metal 3D printing. They are located in Atlanta, Georgia. They are ISO certified and ITAR registered. On today's agenda, first we're going to talk a little bit about the additive manufacturing landscape. We'll go a little bit into the establishing the business case for additive manufacturing, and then we'll go into the meat of it, talking about the pros and cons of either purchasing 3D printing equipment or contracting to a service bureau. So let's get into the additive manufacturing landscape here a little bit. First of all, there are a variety of different additive manufacturing technologies that exist on the marketplace today. There are over 1,200 different materials that exist. This encompasses nylon materials, plastic materials, composites, and metal materials, and ceramics as well. But why exactly does 3D printing exist? We're at a plastics show where injection molding reigns and rules supreme. Let's talk a little bit about the benefits of 3D printing, which is ultimately about the designing for additive manufacturing. The first one we'll talk about is increased part performance. For example, the development of internal channels for certain products. Instead of machining a part that might be impossible to machine or very difficult or costly to machine, you can actually create internal structures with 3D printing. This is highly relevant for fluid, air, and gas devices, and you'll see this in the aerospace market, energy market, and the medical device market. The next one is about product customization. So we see this a lot in the medical market where you're seeing custom orthotics and prosthetics. Next one, we're going to go into topology optimization and lightweighting. So the inherent benefit of additive manufacturing as opposed to subtractive manufacturing is adding material where is necessary, indicating that there's less waste, and at the same time only putting material where you need it. Lightweighting has been a huge benefit, again, for aerospace and automotive industries particular because of the savings on fuel. Next, we have zero tooling. This might be interesting for a lot of people in the NPE audience, and bridge production applications. So instead of spending a certain amount of money on any kind of tool that you may need, you can actually just 3D print that part on demand. And then finally, part consolidation. Whereas we would work with 5 different suppliers to get 5 different parts, we can actually 3D print that assembly in one singular piece. I show this on the screen. This is the entire mixture of the additive manufacturing OEMs. In the top left corner, you will see the polymer machines, you'll see the metal machines, you'll see a handful of different software companies, and then you'll see material providers as well. As I mentioned before, this encompasses a lot of different materials between plastics, metals, composites, ceramics. It's really important to understand all the different nuances that go into that. And then we have to keep into consideration what the future of additive manufacturing materials is going to look like as well. Most notably, conductive materials such as silver and copper, and we'll also talk about refractory metals such as tungsten and rhenium for high temperature applications. Finally, the last thing I want to note here is that you will notice that the HP logo is both in the polymer and in the metal section of this graph, indicating that they are one of the few companies on the market that offer both polymer and metal 3D printing services. This company, HP, came into the market about 8 to 10 years ago, and they helped create a lot of awareness within the industry, and of course they continue to use their same rigidity when it comes to testing and validation to provide a repeatable industrial 3D printing solution. So we've talked a little bit about the additive manufacturing landscape, we've talked a little bit about the players involved, now let's talk about the market trajectory. This information was provided by Smart Tech Research, and what you see here is in 2024, the estimation is about 200 million 3D printed parts globally for production use applications. By 2030, that number is expected to go 3x to be 600 million 3D printed parts produced globally using 3D printing. There's drivers on the left side that we talked about in regards to the different applications that are used. And then most notably, you'll see the healthcare and consumer goods industries are the ones that are making the biggest impact. One interesting note is currently today about 90% of the drivers is going to be for polymer plastic parts in 3D printing. By 2030, that number will shift to about 80% polymer, 20% metal. I know this is a plastic show, but I would recommend to keep an eye on the future of metals in 3D printing. Now let's get to establishing the business case for 3D printing, where we can talk about whether or not you want to purchase a machine or you want to outsource to a contract manufacturer. And the first thing I want to share is an initiative, a White House-backed initiative called AM Forward. AM Forward has two goals. The first goal is for defense and government spending to do more additive manufacturing parts here in the future. And the second part of the initiative is to work with more subcontractors and machine shops. So we're already seeing it within the defense industry that there's a huge push for not only additive manufacturing, but working with subcontractors. So this actual initiative, you'll see companies like Boeing, Lockheed Martin, Northrop Grumman that are now focusing on working with more machine shops. What does that say to us as the rest of the market? Whether you are serving your internal or external customers, or you are a machine shop that does CNC, injection molder, laser cutting, you are going to have to innovate and differentiate in the future. When your customer comes to you and asks to consider 3D printing, you need to make a consideration about whether or not you need to purchase equipment or you want to consider outsourcing. One other note that I want to quickly mention is that in my career and what I do is I try to follow the money. And I gave an example of what the United States government is doing for defense applications. The other one I want to quickly mention is the semiconductor industry. There is a lot of money being poured into that right now, and I highly recommend anybody who's interested in that to take a look at what we're doing in the United States for semiconductor and chip manufacturing and the implications of that for 3D printing here in the future. So when you decide if you want to either purchase a 3D printer or outsource, you have to start with an internal, honest assessment of what you are capable of doing. So an internal analysis, right? And the first thing starts with application. What exactly are you going to be 3D printing? That is an easy, obvious first step in the process. The next one is 3D printing experience. There's a big difference between having a $3,000 3D printer and a $300,000 3D printer. In addition, I've worked with many different companies before in the past that have siloed divisions, whereas the company in California may be doing 3D printing, but the company in Minnesota is not doing 3D printing. So having access to the collective 3D printing experience within your organization is very important, can't be underestimated. And you actually have to ask yourself, if you were to buy a 3D printer today, who would own that and operate that 3D printer within your department? The next is very obvious. It comes down to skills and tools. The first one, skills, designed for additive manufacturing. It's great to have CAD skills, but if you can't take advantage of the 3D printing benefits that come with designing, then you have to make a consideration of what that's going to look like for your individual business. And of course, CAD tools and reverse engineering 3D scanning tools are also very valuable. The fourth consideration in your internal analysis is going to be facility requirements. So when you consider a 3D printer, whether it's a polymer machine or a metal machine, there's certain facility modifications that you need to take into consideration. This could be ventilation, material handling, powder management, electrical and plumbing. All of that needs to be taken into consideration. I've worked with plenty of companies before in the past that new construction and renovation projects can get very costly very quickly. The final consideration is your budget and return on investment. Now, if you're a research and development laboratory, you are less interested in return on investment, but if you are Endeavor 3D or a contract manufacturer or many of the other manufacturers in this exhibition hall, return on investment is necessary. It could be as short as 18 months for a piece of equipment. It could be 3 years. It could be 5 years. That is very important to take into consideration. And on top of that is going to be your actual budget that you need for a 3D printer. And I want to bring some transparency and some clarity to this conversation. In this pie graph, you will see that the cost of the 3D printing equipment only encompasses about 60% of the total cost of ownership. So you need to think about what else is going to go into this? And one of the biggest pieces of this pie is going to be the maintenance contract. Maintenance contracts for a 3D printer or any kind of hardware system, those contracts can range from 10 to 20%. So you need to take that into your thought process, and that where are you going to be in 3 to 5 years? If you have an industrial piece of machinery, you would rather have a maintenance contract than not need it, than to need it and not have it. The next few things you need to take into consideration: installation and training, post-processing equipment, and then of course labor and consumables. And if you go through your internal analysis and you find out that some of these circles are red, then you may want to consider outsourcing to a contract manufacturer. So let's look at the pros and cons of working with a contractor. We will start with lower overhead costs. This is an obvious one, right? You don't have to bring the equipment in, you don't have to do any kind of construction, you don't have to pay somebody to operate the machine. They literally just send the file over to the contractor, and they can 3D print that part on demand. Which brings it to the next one, an on-demand resource, being able to 3D print parts in as less than a day and getting them in your hands anywhere from 3 to 5 days, depending on your scenario. Technical expertise, and this is a really important topic. Contractors like Endeavor 3D work with a variety of different companies from a variety of different industries. On day one, they could be working with a satellite company developing on a new Cube satellite device. On day two, they could be working with a company that's doing custom orthotics. And on day three, it could be a consumer product company. So having that range of experience across several different industries enables the technical expertise internal at Endeavor 3D to share that with you free of charge. That expertise is impossible to find other ways. Quick scalability. So once your product goes to market, and you can either go directly to tooling, or you can actually scale up with your contractor very easily. I can tell you that Endeavor 3D has a 65,000 square foot manufacturing facility, quick for scalability and also quick for fulfillment and packaging. The final piece, which is always interesting, is no obsolescence. In our society and in our commercial world right now, planned and perceived obsolescence is a huge concern. Where is your machine going to be in 3 years? When new materials are introduced to the market, will they be available on your 3D printer? And at the same time, will there be an upgrade path for your 3D printer in the future? Working with a contractor, no obsolescence problems. But of course, there are always going to be downsides. And the first obvious one is premium part price. All those different characteristics that we talked about before that go into the cost of a 3D printer, the space, the laboratory, the technical expertise, the materials, the cost, the maintenance contract is all built within the price of the part that you get from Endeavor 3D. Now, you can get any type of part that you want 3D printed on demand, but of course you're going to pay a premium price for that. The next one is partner reliability. Finding an important partner will always be a challenge, and it should be very obvious to everybody in this room that if you're going to work with a contractor, you need to vet them out thoroughly in order to think about if they are going to work within your business. IP and security risks. This is a very important conversation right now as the supply chain is changing and transforming. Once you share information with a contractor, you want to make sure that it's not only shared correctly and safely, but that it's stored correctly. Endeavor 3D is ITAR registered, therefore they have certain protocols in place to take care of all the information that they collect during the customer relationship process. The final is the onboarding process, and this is for information for everybody to consider that when you start working with a contract manufacturer, it's important to set the right expectation. And what that means is time, quality, and cost. What type of quality measures are put into place to make sure that my parts are always going to be on time and on spec? Also, what are the costs that I'm going to be expecting here in the future? And can you give me a reasonable expectation of what the lead time should be for when I want to order my 3D printed part and when I'm going to get it? Because if you ever need a part faster than you ever did before, you have to expect that there's going to be a price increase. Therefore, you have to set the expectation during the onboarding process. Finally, as I wrap up this presentation, I want to quickly summarize what we've done here. If you have any other questions for me or anyone about Endeavor 3D, you can come and ask directly. First, the AM market is growing. Second, it's important to understand your business case and your application and your total cost of ownership. Third, always conduct an internal AM audit, no matter if you're purchasing or outsourcing. Understand the entire breadth of 3D printing experience within your business. 4, have clear owners of 3D printing. 5, set expectations with your contractors, specifically for time, quality, and cost. And if you've taken all of these into consideration, maybe it's a combination of in-house technologies and outsourcing that you may want to consider. I want to say thank you very much for everybody, and thank you, Endeavor 3D, for having me.